Hello and welcome back. Today we reviewed part 3 on big data management. It covers databases, Hadoop, integration. It's solid technical stuff for a CS audience. Let's dive right in.
Sounds good. Lots to cover there.
Yeah. So a big theme is using different kinds of databases together, right? This polyglot persistence idea. Let's start there.
Okay.
While the material does a good job listing the different database types out there for big data, the strategic advice needs a shift. It needs to go from just defining categories to giving a real, actionable way to decide which to use when, a framework for polyglot persistence.
That's a good point. Chapter 7 lays out the non-relational options well. Key value pair, document, graph like Neo4j, spatial. And it's right. Polyglot persistence is pretty much the reality now.
Weighing the crucial architectural trade-offs you make with each choice. We need to help the reader move past just knowing the options.
Right, move from description to actual architecture. I see. So the suggestion is to beef up that Chapter 7 conclusion, add an explicit comparison?
Exactly. A comparative framework. Something technical readers can use to pick the best model based on what the business actually needs. Comparing things like performance targets, KPIs, and what kind of transactional guarantees are required.
That makes it much more practical.
It does. So for concrete examples, instead of just defining KVP stores, you contrast the scenarios. Say you've got high volume, low latency needs, data is mostly strings, and eventual consistency is fine.
That classic NoSQL use case.
Right. Then you explicitly recommend KVP databases, maybe like React.
And when you mention React, you definitely want to highlight why it's good for that, like its resilience, the peer-to-peer setup, the gossip protocol mentioned in Chapter 7. Connect the tool to the reason.
Precisely. Give it that operational context. But then, flip side. If the app needs really strict consistency, structured queries, where data integrity is absolutely key.
Then you steer them towards something like Postgres.
Yes, and you highlight its SQL standard support, its proven ACID properties, like the text details. Make the contrast clear.
And for complex relationships, like mapping social networks or biological data.
Then you stress why you'd need a schemaless graph database like Neo4j, which Chapter 7 also covers, showing KVP for speed, Postgres for consistency, Neo4j for connections. That gives immediate practical guidance for a CS grad or practitioner.
That definitely elevates it from just a list of technologies to actual architectural advice.
Okay, so that covers picking the databases. But then you've got to actually process all that data, usually at scale, which brings us to the whole Hadoop ecosystem.
Right, the next big section. Chapters 8, 9, and 10 go deep into MapReduce, HDFS, the core stuff.
They do. The foundational descriptions of MapReduce and Hadoop are thorough, no doubt. But to be more relevant for an expert audience, it could focus less on just defining components and more on the tricky parts. Optimizing and managing these things when they get really massive.
Yeah, the descriptions of name node, data node, even tools like Pig and Scoop are well covered. But for someone who already knows distributed systems, the real challenge isn't just knowing what Yarn or Zookeeper is.
Exactly. It's knowing how to actually manage the complexities they bring. How do you tune them to hit performance goals? How do you make the cluster resilient in production? That's where the pain points are.
So less definition, more strategy for managing complexity. We need to shift the focus a bit, acknowledging the reader's existing knowledge. Talk about the tougher operational challenges, resource management, fault tolerance in that Hadoop world.
Okay, so let's take Yarn, yet another resource negotiator. The discussion needs to go beyond just defining the resource manager and application master roles.
Needs more depth.
Yeah, focus on the risks if you don't schedule properly. Just knowing the roles isn't enough. Real management means tuning the scheduler. How do you prevent latency spikes when your cluster is elastic, scaling up and down with demand? Chapter 6 touches on dynamic scaling, but we need that operational lens on Yarn specifically.
That's a much more advanced angle. And what about resilience?
This is a great place to use those topological details mentioned in the text. Make it a clear management choice. You highlight placing Zookeeper across racks. That's for better resilience, better fault tolerance, keeping coordination solid, like page 128 mentions. It's a safety play.
Contrasting that with HDFS.
Exactly. Contrast that immediately with HDFS needing data nodes to be rack-aware, which is on page 114. That's primarily for performance, high throughput, keeping data local.
So you juxtapose Zookeeper's cross-rack setup for safety
against HDFS's rack awareness for speed.
Right. That contrast shows strategic operational design, not just component descriptions. It's the kind of thinking experienced engineers do.
That definitely adds value for the target audience. Takes it beyond a textbook feel.
Agreed. Okay, final main point. This is about integration, connecting all this big data stuff back to the traditional systems, the data warehouses.
Yes, the bridging challenge.
The material rightly points out you need to integrate big data with traditional data warehouses, but it really needs to tackle head-on the critical technical challenge. How do you manage transactional integrity when you're mixing these new polyglot systems with legacy ones?
That's the crux of it, isn't it? Chapters 11 and 15 talk about hybrid approaches, using tools like Scoop or Flume, but they kind of gloss over the inherent conflict between systems with strong RDBMS asset guarantees, atomicity, consistency, isolation, durability from page 55, and many NoSQL systems that operate on eventual consistency and flexible schemas.
And it's a huge risk. The text even mentions big data sources can be dirty on page 147. That's putting it mildly sometimes. If you feed unverified, potentially messy data back into your core transactional systems, well, that's a recipe for disaster.
So the integration discussion feels incomplete without addressing data quality and veracity. The suggestion then is to really emphasize managing data validity at that integration point. Lay out specific governance steps, technical checks, ways to ensure the data coming out of the big data analysis is actually safe to ingest.
Needs concrete actions, like when discussing moving data with Scoop, a key tool mentioned on page 126, it should state clearly data pulled from, say, HBase must go through rigorous validation before it lands in an RDBMS or warehouse.
You have to protect that RDBMS's asset guarantee.
Absolutely. It's non-negotiable for many systems.
And maybe suggest specific management actions, like using data profiling tools on the Hadoop cluster itself, which page 191 touches on. Use those to spot errors, duplicates, weird values, unverified stuff before that data gets used for decisions down the line, like Chapter 17 discusses.
Exactly. Building in that validation layer makes the whole integration process trustworthy. It directly tackles the veracity problem with data coming from diverse, high-volume sources. That makes the strategy robust for real-world mission-critical use.
Okay, that covers the main points. So, this material is a really strong technical foundation in big data management. To just recap the key feedback, the actionable suggestions to really enhance it for the reader. There are three main areas.
Right. First, sharpen the guidance on choosing databases. Develop that stronger architectural decision framework for polyglot persistence. Focus on the trade-offs, the KPIs, the consistency needs, not just definitions.
Second, elevate the Hadoop discussion. Go beyond basic component descriptions to tackle advanced operational complexities. Specifically, how to optimize YARN resource allocation in dynamic environments, and the strategic management of resilience through topology zookeeper across racks versus HDFS rack awareness.
And third, strengthen the integration story. Explicitly address that critical challenge of managing transactional integrity when mixing ACID and eventually consistent systems. Emphasize mandatory validation and profiling steps to ensure data veracity before it hits traditional warehouses.
Implement those changes, and it really sharpens the strategic value for practitioners. We think this will make it an even more essential resource. Please feel free to submit the revised architecture back to us when it's ready.